presentation of this session. We have speaking with us Jia Xie and Sukman Yip from the Heidelberg Center for Transcultural Studies at Heidelberg University. And their paper is entitled Making Ground Truth for Republican Chinese Newspapers, Taking Jing as an Example. I yield the floor to you for your presentation.
Okay, thank you. Thank you, Dr. Robke, for introducing us. Let me share my screen first. Okay, can you see this screen?
Yeah, working.
Okay, so hello everyone. My name is Xie Jia. Today, I will, together with my colleague Sukman, introduce our project. We are from Center for Asian and Transcultural Studies at Heidelberg University in Germany, which is my video background today. And we are doing the infrastructure of Chinese material. Our presentation is about the editing of ground truth for a machine learning task for Chinese newspapers from Republican time. It is a part of our whole project, Early Chinese Periodicals Online, or ECPO, ECPO database. Before we start talking about our paper, here are some contexts I would like to give. First is about ECPO. It is an open access platform started many years ago. We have a big collection of women magazines and entertainment newspapers, as well as many other publications from Qing Dynasty to Republican China. Totally more than 300 publications. If you are interested, please take a good look at the website and do use it for your own research. It can be very handy and helpful. We do not only expect to have collections of publications, but also want to produce machine readable or copy and pastable data from the publications we have. To reach this aim, we are trying the method of machine learning to help us. Our presentation will mention how we edit the data the machine learning needs and what problems we have met, and hope to provide our experience for you, for all the researchers processing NLS, non-Latin script. We select one newspaper to do our experiments. Our material used is the Crystal Jing. It is one of the typical entertainment tabloids in Chinese, Xiaobao. It had a long running history of 21 years. There are like nearly 10,000 scans, a big number. That's why we choose this for the experiment to produce full text data. To do this, we meet two tasks. One is page segmentation. The other is character recognition. These are the two directions of our ground truth editing. Why we need ground truth is because we want to apply neural network method. It is now often used for character recognition. I'm showing the example of ICDA challenge and the very impressive paper by Lieber and Burkhardt, who evaluated different CNN, the convolutional network, neural networks on their newspaper material. There are already some projects about the newspaper and the page segmentation, like the European newspapers, Impresso, News I, and OCRD in Germany. However, they are mostly designed for Latin material. And what we need now is a free and open source, open access tool. So we tried, for example, the DH segmentation to do this. Our approach is to apply the neural network for page segmentation, and we train models to detect the content types, such as the titles, the margins, ads, images, and so on. And the prerequisite for neural network is a good ground truth. Oh, sorry. I should not click on this. Now, about the ground truth, what is the ground truth. Some of you may know neural networks means the machine learns to recognize certain patterns, and training as much as data is very important. Therefore, we need a very correct standard to make sure the machine can learn the very right thing. We prepare this manually, and that is our ground truth. We use our data to train the neural networks and evaluate the results and rework when necessary. So our data set has two parts, as I just mentioned. The first one is the geometry data set, which is used to describe the page segmentation, including the number of the coordinates, for example. And the second one is the text ground truth. This is the key point in our presentation. This shows the structure and the characters printed in the newspaper. I will very quickly go through the two ground truth data sets. The geometry data is visually the bounding boxes. As the picture shows, they are these are stored in JSON files. And the text data was produced by student assistant. This is written in XML. Let me go to more details later. First is the geometry ground truth. I will explain how we create them. We use a tool that's developed from the exist solutions, which allows us to use our mouse to finish this task. The different colors of boxes represent different types of contents. For example, blue for images, yellow for articles, green for ads. The purple for special information, usually some self-announcement from the newspaper itself. There are some common mistakes might happen in the process, in the progress, such as the blocks are set into wrong color, wrong types, and because of the limited knowledge of Chinese texts, it is likely to mistake which blocks should be together or not. And then we use one color for all the small units that belong to one article. In this way, we can also clearly get how many articles are there in one fold. Here is an example of our outcome, which seems very nice. So the second part is the text ground truth, which is the key points. Today, we use XML to store the data. Our team has set several XML schemas, which differentiates between folds, divisions, and pages, articles, images, paragraphs, as well as line breaks, page breaks. We recorded the characters according to the original text and used the respective Unicode code point as far as possible. And this is how our ground truth looks like. It's an example. At the very beginning of each page, we define the default running direction of the text in the highest level of div elements. Here as vertical right to left, and the reading direction is right to left. For passages with different running directions, we can change in the sub-level divs. About our editing team, here's a photo of our team in the library of Transculture Center in Heidelberg. More information can be found on our website. We are divided into two groups and use the mode of blind double keying, which means each group independently enters all the data. We only deal with the article contents in the newspaper without advertisements, because the advertisements are usually more complex and we cannot apply the neural network methods to them so far. As the picture shows, we type the characters of one article into XML. My colleague Sukman, together with me, were the supervisors of two groups. We selected the undergraduate student assistants and trained them. This included special features because of the traditional Chinese characters and certain specifications for the imports. We also did a final review of the texts and generated a final version after comparison. The benefit of double blind keying is that we could easily find out what is different typed from two groups. For example, these two characters here have only very slight difference. The software can help us to find such places, so we can make it very quickly. And all of our data is publicly available on the GitHub website. If you search for ECPO, you can find it. Now let me hand over to Sukman.
Thank you, Xie. Good afternoon, everyone. I'm Sukman Yip, and I am another supervisor of the Breakthrough Working Team of the ECPO team, ECPO project. Xie and I was responsible to supervise two editors on the typing and editing works of Team Bao. And the part I'm going to present is old tests in new formats, challenge in encoding Chinese characters. In this part, I will present two of the encoding issues that we encountered during the inputting process. One is the variance issues, and the other one is the typographic issues. And one of the rules that we have, that is to input what are exactly printed on the newspapers. Therefore, we have to input exact Unicode code point of the Chinese characters to the XML file. And so what is Unicode code point? I think most of you may already know that, but let me just briefly introduce it. Unicode code point, in fact, every Chinese character has a code point to represent. For example, the character Yan, Ren, that means human. Its code point is U plus 4EBA. And to input this Chinese character, we have to type the correct Unicode code point. However, we find a big problems when we input the Chinese old newspaper in the Republican period. Many Chinese characters have variants. And now you may have another questions, that is, what is variant? 一台几, 一体制. Chinese characters always have many different forms. You can written it in many different shapes. For example, like this character, 真, 真, that means will or truth. We can write it like the one on the left, or write it like the one on the right. And next slide, please. And these two characters have the same meaning, but have different shapes. We call the one on the left the regular, 整台制, 正体制. And the one on the right, we call that as variant, 以台制, 一体制. They have different shape, but they have the same meaning, and also both characters are correct. So you may ask another questions. So if both of them are correct, then what is the problem? The problem is most of the variants have different Unicode code points. Like the characters here, we show you these four characters. 真, that means truth, I already said, and 教, gao, that means teach, and 说, that means speak, and 为, why, that means make. These four characters have different shape, but the same meanings, and also have different Unicode code points. Then to make the previous slide, still the previous, yeah, thank you. So to make the machine read the Chinese more accurately, we have to input the exact Unicode code points. Therefore, when the newspaper use those characters in the right column, we should type the code points in the right column. And when the newspaper use the one in the left columns, we should type other code points that are actually in the left-hand side. And today, people mostly use the regular one. But during the Republican period, one can find both variants and regular Chinese characters in the newspapers. Sometimes the regular forms and the variant forms even appear in the same paragraph. So we need to be very careful when we're inputting the passage. Our team have made a table on our GitHub. The variant we have found in Jinbao so far. In the table, we list the regular forms, their variance form, and also their union and their Unicode coupons, so that our teammate can check the details when having problems during the inputting process. And also to confirm the Unicode coupons of some rare Chinese characters, we check the correct coupons on some very useful websites, such as Handian, Hongdian, Unihan, and Chuanzhihu, extra and extra. We also list them on our GitHub for reference. So I just present the cases that the regular form and the variants have different Unicode coupons. And in some cases, the regular forms and their variance forms have the same Unicode coupons, like these 4 characters. They have different shape, okay, but they have the same Unicode coupon. So in these cases, we don't call them as variants anymore. We call these characters as a glyph. That means we consider them the same as the regular form, but just with some ornaments only. And in these cases, we input the only Unicode coupons into our XML file. So we won't insert any extra orders or message. Next. And there are also some very rare cases. We found some characters have no Unicode coupon. For example, like this character, Jing, Jian. We use the one on the left today, and the one on the right-hand side appearing in Jinbao have no Unicode coupon. You can see that it has an extra component, Yang, Ren, that human component, in the middle of the character. So in this case, after typing the character Jin, we input a comment and add a IDS for reference like this, like the sentence in red at the bottom. Next page, thank you. And now I would like to move to the next part to elaborate on the typographic problem. During the inputting process, we found quite a lot of typographic issues that may confuse the machine and affect its Chinese learning progress if we don't deal with those issues carefully. One of the typographic issues is the rotated characters. Like this character, 表, 表, that means representative, surface, or table. And the character, now you can see that it is rotated 90-degree clockwise. And the correct one should be printed like the one on the right-hand side. And you may have questions when you see this character. Why was the character printed like this? It was because the old Chinese newspapers and books were printed by a block with many small cubes. Those cubes are movable. And this printing method is called movable type, 物质印刷术, 活字印刷术. Every cube has one Chinese character. When the printing worker put the cube in the wrong direction, the character became rotate, like this character, gu. And you can see that it was placed in the wrong direction. And it should be placed like the one in the middle, and then it would be printed correctly. Next. So in these cases, when we find some rotated characters, like this character bill, we input a sentence like that, like the red sentence. And this sentence can let the machine know that here is a rotated character, so that it won't read the character as the usual one. And we'll notice that that is a rotated character. Besides, because of some printing problems, for example, too much ink or too less ink, or sometimes uneven ink spreading, some characters are illegible in the newspapers. For example, like this character, we can only see some very bird stroke, but cannot recognize what this character is. So in these cases, we input this signal, 改记, to teach the machine that it is an illegible character. And sometimes there is a missing character. Many possibilities may cause this situation happen. For example, when all the groups with that character has already been used, so the printing worker could only use a blank group to occupy the space. And in this case, we don't want the machine wantonly recognize that space as a character. So we, in this case, we input a full space whose Unicode code point is U plus 3000. Then that can let the machine know that there is a character missing. And there are still many issues and special situations that we have encountered. However, because of the time limitation, I'm not able to elaborate all of them this time. So for the details, please read our papers. And with the very careful inputting, editing, and also proofreading procedures, here is one of the digitized files of Jingbao that we made, and it will be used to teach machine how to read Chinese. So it's the end of my part. Thank you very much. And now I will hand over to Xie again, and he will summarize our today's presentation and tell you some future plans of our project. Xie.
Okay, very briefly. Thank you, Sukman. I come to the summary and outlook. What we have achieved so far is basically the BA thesis by Konstantin Henker, one of our team members. And in his paper, he has done with the regular grids. On the left side, you can see the characters are in regular grids, but on the right side, they are irregular. So what we have done right now is only the regular one. And with a very good result with character error rates smaller than 3%. So because of the changing of the printing technique, we need to solve the problem of the irregular grids, and that is what we are doing now. So here are some statistics of Konstantin's bachelor thesis. As you can see, we have got a very good rate. To view more the details about the technical, and you can read Konstantin's bachelor thesis or watch our video. It was a presentation at Confucius Institute, but it is in German. Next course is we expect to apply our method to the irregular ones and to the other parts of Jingbao. And then we want to extend to other similar newspapers in ECPO. We encourage every researcher to use our data. Our data will be open access in the future. Even the whole the database, the Akpo database, all the data will be open access in the future. I will upload them to GitHub. Here are some selected references, and many thanks for the attention.
Thank you very much for the incredibly interesting presentation. It's pretty exciting. I imagine there are plenty of questions and comments. Yes, Madalena.
Yes, thank you very much for this project. It's really, I don't know, I'm really excited about it. And I will ask a question which is a bit unfair, but because it just started, right? But I'm wondering if you have thought also about adding translations to all this material. And the reason why I'm thinking that is that while you were talking, I was thinking about using this resource for teaching, to find material to teach. And by and large, people who teach modern Chinese history or anything related to that do read Chinese, but there might be other people interested in this, and they may not have Chinese language among their skills.
So for our projects, let me first explain right now this OCR project. It's all of the documents are in English, but we have not translated the content of the newspaper, of course. But in the Akpo database, we have tried to translate all of the metadata of, for example, the title, the author, and the title of the articles in the newspaper even. Right now they are in English, and we are trying to build a multilingual infrastructure in the future. That's it, basically.
Yeah, I know. As I said, it was a bit of an unfair question because it's just the beginning, but thank you. It's really exciting.
Yes, we have another question from Giet van Kerbergen.
Yeah, thank you very much. I also think it's a very exciting project. And what I'm wondering about is, and this is more for Jip Soekman, let's say when you have that character that was rotated accidentally, and you tell the machine, we're going to, this is a rotated character. In your ultimate version, or perhaps even edition, are you going to turn the character upside down, or is the user going to be aware that this is a rotated character?
Yes, for that example, in fact, before we inputting the newspaper, we haven't realized that there may be some character rotated or upside down. But after we input those newspaper and we check it, editing it carefully, we find some character is rotated, not only 90 degrees clockwise, maybe upside down, or 90 degree anti-clockwise. And if we just leave it, let it go, and don't take care about those characters, that may make the machine have some wrong message, collect some wrong data, because they have to read that character exactly like the newspaper shown, so that they can analyze, oh, that character, the machine just read it, is that character. But if the character is rotated, then the machine may get some wrong data. Yes. They may think that, oh, that is also the same character, but in fact it isn't. That's why we have to insert a sentence that is an order to let the machine know that that character actually is rotated. So when you read it, you can't collect the data just like you read it as a usual one. You need to sort it as the rotated characters. So it won't affect the data the machine already collect, and also won't affect the accuracy of reading Chinese. That's why we have this arrangement. And at this moment, after we have doing such arrangement, and we find that the accuracy of reading Chinese for the machine is enhanced than the before. So that means we will find that this kind of very slight adjustment is still very useful, very helpful for the data collection for the machine reading.
And in the future, we will publish all the full text data on the website, and we will tell the readers here is a character rotated, of course.
So they will know. Okay, yeah. Because in a sense, it's interesting information that would disappear if you don't. Yeah, thank you.
Yes.
Yeah, thank you.
Thank you for those questions. I saw there were some more, but let's put those back. We'll postpone those for the question and answer session later so that we can keep on our schedule.